So why are we here talking about REST? Dr. Fielding, in his thesis in 2000, his PhD thesis in 2001, came up with this architectural style for data interchange between systems, and he labeled as REST, which stands for representational state transfer. And these are the 6 principles of why he believes REST is a useful architectural design pattern. I'm not going to go through these too much. Just note that he covers them all in his thesis, but just very, very briefly, scalability here is not really about performance at scale, like number of machines that you deploy to handle kind of traffic. This is really about use case scale, meaning internet-wide, global-wide scale. How can something in the healthcare industry interact with something in finance or that kind of scale, internet-wide, cross domains. And that generality is really about general purpose, ease of use. You should be able to handle any type of scenarios. Independence, you should have independence from third-party systems while still being able to be flexible to build out your own. Latency and caching are built into the HTTP spec. We'll talk about that in a little bit. Security is also important for REST, and there are many different techniques about this. We'll cover some of that at the end if we get some time. And encapsulation means that you can represent or provide a RESTful interface without exposing your internal details to the world. JSON, why are we here talking about JSON? It's obviously popular. It's kind of the de facto web standard now, or web language. There's all these benefits. I'm not going to go into that. If you're here at this presentation, presumably you know that REST and JSON are interesting. But if this presentation is about REST with JSON, and it's just JSON, it's just HTTP, those are well defined. Those things have been around for decades now. So the assumption is that REST is easy. If it's just JSON, it's just HTTP, there's not a lot to worry about. And the reality is REST is actually really, really hard. And the reason for that is that there's no specification. There's no formal IETF, RFC, that states this is exactly how a REST API should look. This is the media type that should be used. So if anybody tells you, oh, the REST spec says this, they don't know what they're talking about. There is no REST spec. There's Fielding's thesis, but it's not a specification of inputs and outputs and expected results and test criteria and such. So, there are best practices, though, and we want to codify those and represent them faithfully. And we're actually in this ION spec that I'm going to talk about is actually a big attempt to finally do that in the industry. So REST can be easy if you follow these the best practices that we're going to talk about today. There are a lot of different edge cases and things to discuss, but if you can whittle things down into some basic fundamentals and build on top of that, it'll be easier to deal with. How many people here have heard of Hadios? So we got some, okay, good. So there's some folks that have. Hadios is a mouthful. Hypertext as the engine of application state. And that mouthful really means, how do you represent a data interface that is fully self-described such that maybe you can land on one initial resource or page or whatever you want, document, whatever you want to call it. And then from there, you should be able to do whatever you need to do throughout the duration of interaction with that site or that domain without ever having to look at documentation. It should be fully self-described to whatever client is being used to interact with that data, such that the client can navigate across page boundaries or document boundaries or resource boundaries, whatever you want to call these things. Hadios is all about having the state inside of the resources that you're interacting with so that you don't need to interact or interface with out-of-band information like documentation or things like that. Everything should just work once you land on that initial page or document. So more specifically, Hadios, Fielding really refers to this as two different things. You have to have links, meaning you have to have a document or a resource that can reference another document or resource. And you need state transitions. So a resource can be updated from one state to another state, or you can traverse from one resource to the state of a different resource. REST at its very core, if you're going to do it the right way, according to Fielding, is based on these two things, linking and state transitions. And so he breaks this down a little bit further to what he means, or rather sort of implications based on these two concepts. The presentation video will be online later, so you guys will be able to get this link if you can't write it down quickly enough. But in this post that he writes, he really outlines some core principles to being RESTful. And he's very, very clear about what he means by REST. In other words, if you don't adhere to these things, he doesn't want you calling your API RESTful. And I will promise you, the vast majority of people in the industry, Stormpath included, are not actually true REST APIs. We're getting there, and with specs like Ion that we're going to talk about today, we're finally going to be able to have something that allows you to be truly RESTful according to these principles. So Fielding states whatever REST is, it should be communication protocol independent. So whether I'm using HTTP or raw TCP/IP sockets or some other mechanism, my state representation in my data should not be protocol dependent. It should be independent. And that means that in a sort of a subtext for this, he's also stating you don't want to change any existing protocol in order to support REST. You don't need to. If the state of what you care about is in the data that's transferred back and forth, you don't need to modify the protocol to support REST. So it should be communication protocol independent. It should be media type centric. And this is something that a lot of people get confused about. You know, the media types, are they schemas? Are they parsing rules? Like what is a media type? We'll talk about that in a little bit. But one of the best ways to get true REST is to have a media type that allows clients and servers to investigate content in order to go through these links and state transitions. So if you're building a REST API and you're not defining a media type specifically other than just application JSON, it's probably a good indicator that we're not adhering to Fielding's kind of requirements for true REST. There should be no fixed names or hierarchies in a RESTful scheme. Meaning, like, if I go to a domain like foo.io/API, from that point on, there should be no preconceived notions of what paths exist. So clients should never, ever hard code, oh, if I go to foo.com/API/users, I know I'm always going to get a user list there. That endpoint might go away. The client might get a document that states that it's a completely different location under a different URL. So Fielding's very careful to represent that there's no fixed hierarchies, no fixed structures. It needs to be completely dynamic. And so does the information within documents. So if you want to think about this in a programming sense, true REST is dynamically typed. Like if I go to a particular URI today and I get these fields in a JSON document and I go back tomorrow, it might be completely different. And the clients need to be able to respond to that. No hard coding. This is really difficult for type-safe developers, like if you develop in Java or C# or what have you. Some of these concepts are hard to get over with, because if I want to represent an account, I should always have these 10 fields or whatever. That's not truly RESTful. In order to hit that internet-wide global scale concept that Fielding was talking about, clients need to be dynamic and be able to react to change on the fly. And there's a clear example of how this works that everybody is familiar with that we'll talk about in a little bit. And probably one of the most important things, as I hinted at before, is zero out-of-band knowledge. I should be able to land on specifically REST with HTTP. I should be able to land on a particular URI, and from there access everything without ever reading a line of documentation. If we don't do these 5 things, then we're not RESTful, and Fielding doesn't want us to call our APIs RESTful. We can call them something else. We can call it Web RPC or whatever, but he says if you're going to use my name, you got to make sure these principles apply. So the vast majority of our industry does not do this stuff. So don't feel bad if you don't have a truly RESTful API. The whole point of this presentation is to give you the tools to get there. So how do we meet these requirements? What are the things that are involved when you're building REST APIs? You have to worry about what's your base URL, what versioning strategy are we going to use for our API? How do we deal with method overloading and errors and pagination and querying and all these other things? We're going to dive into this stuff to the best of our ability given our time frame that we have. But before we dig into some of these specific techniques, I want to cover some fundamentals first. So what's a resource? You heard me talking about this notion of a resource or a document that can link to others. Resources at their very core are nouns. They're not verbs. So an account is a resource. A group is a resource. A credit card is a resource. These are all things. They're not verbs. They're not delete or update or whatever. And we always want resources wherever possible to be coarse-grained. So if you can get a lot of functionality or a lot of stuff into a single resource that meets a valid use case, you want to do that. You don't want to have many different resources where you have to traverse and get all this information and assimilate it, because coarse-grained resources give you better scalability from a use case perspective. If I have one resource that allows me to do 10 things as opposed to one that only allows me to do one, you're going to get a lot more bang for your buck, if you will, when you're building out your REST APIs. And so that really affects, as a design perspective, the kind of use case scalability you get out of your REST architectures. And so it's kind of to illustrate what I mean by nouns and not verbs. You might have seen APIs that kind of look like this. This is a little more web RPC-ish. What if I had some URIs in a web app where I can get an account or I can create a directory, and again, in Stormpath's vernacular, directory is just a collection of accounts and groups. That's it. Maybe I want to update this particular group's information, or I want to verify an account's email address. This looks fairly innocuous. It doesn't look too bad or too painful. The problem with this, though, is it explodes very, very quickly. What if I needed to search accounts or update groups by name or whatever? And you can see that this will get very, very out of hand very quickly, and you have to maintain this if you're building the software to support this API. So this is not good. This is kind of reminiscent of, early 90s SOAP architectures, and this was very painful, and nobody wants to do this anymore. So this is bad RPC. Don't do this. Instead, we want to focus on keeping things simple. And by that, I really mean that there's only two kind of things you have to worry about in order to handle pretty much all use cases that I've ever seen. And that's to restrict yourself to interacting with resources of two types. You have collections of things, and you have things, right? There's instances of particular data, and then there's collections of multiple things. And so what does that kind of look like in a modern REST app? If I go to a /applications endpoint and on a URL, presumably I'm working with multiple things, potentially. Maybe it's 0, or maybe it's 1, or maybe it's more. The idea here is that the name is in the plural. It's self-describing to, at least to a human, that, hey, I'm probably, it's not application, it's applications. I'm probably interacting with 0, 1, or more things. Conventionally, if you want to interact with a specific application, conventionally, usually you'll have an identifier that kind of hangs off of that collection endpoint. So not only am I interacting with applications, but I'm specifically interacting with this one particular application. Now, you'll soon find that this doesn't really matter a whole lot in REST. Like URL design is basically completely irrelevant because clients don't really care as long as the data is self-describing. But this is kind of really useful and convenient for humans, at least when you're reading or interacting with APIs. So we recommend that you kind of stick to this convention. It makes things easier. Now, if you have resources, collections, and instances, and everything looks like a noun, how do you get behavior out of this stuff? How do I update a particular application or add a new one? And at least in the HTTP sense, behavior is already defined via the HTTP verbs or the methods. Get, put, post, delete, head. There's patch, which we really won't talk about today. But these are the things, these methods afford you the ability to apply behavior to particular resources or across resources. So HTTP as a protocol already has this capability, and web REST APIs leverage these things to enable behavior on specific resources. So if you think of it that way, the next logical step is, get, put, post, and delete must correspond to create, read, update, delete. CRUD, HTTP, one-to-one mapping. It's true you can think of them in that way if you kind of restrict your viewpoint to a particular, scope. But in reality, it's not a direct one-to-one mapping. You can actually, for put and post, which I'll show shortly, you can actually do more than just one thing with those. So I don't want anybody here to get hung up on the idea that it has to be one-to-one and there's only one way to do this. There are valid use cases that are valuable depending on what you're trying to do. Get, head, and delete are really kind of one-to-one though, of that list. Get is actually I'm going to read. Delete is I really do want to remove that resource. Head is a little different. It's really, give me the metadata about the resource. I don't actually want the resource. But put and post are not so obvious. They can both be used for creation and update scenarios. And it's really important to know this because you'll see on the web, oh, put's only for update and post is only for create. That's not true. You can use put for create, actually, if you allow your clients to specify their own identifier when creating a resource or updating a resource. So if the client, if you allow them to do this, depending on how you've designed your API, I can interact with a particular URI, and if I'm using put, I can choose my own identifier. A lot of APIs don't do this, but it is possible. Put can also be used for update. So I'm interacting with the same URI. I'm using put. I have to specify my. In this case, I am, updating a particular application with 2 fields. But one of the interesting things about put is that put is always, and it must always, be a full replacement operation. In other words, anytime that you use a put on a URI, you have to submit the entire resource. You can't submit partial fields. You can't submit a little bit of data. Every single time, the entire data has to go. And the reason for this is it's actually mandated by the HTTP spec. It's not optional. Put is idempotent, okay? And idempotent, if you've never heard of this term, it means that whether I do this operation once, 10 times, or 1,000 times, the state of the resource itself on the server is going to be identical after every single time that I run a put. So HTTP servers or proxies can cache puts. If things go wrong, they can retry them safely, right? Idempotent means it's a safe retry operation and that the state of the server will be the same, rather the state of the resource you're interacting with will always be the same after the put completes successfully. So I can't send in one property on one request and another property on another request because the state of the resource after both of those two is not guaranteed to be identical. Does that make sense? Everybody understand? This is not optional. This is mandated by the HTTP spec. If puts are not the entire resource, you're violating the spec. And bad things will happen, especially with caching and proxy servers if you do that. Okay, post. Post can be used to create. Most of the time you'll see post being used to create resources by interacting with what we perceive as a collection endpoint usually. And in this case, you can put this information in off the endpoint. But because the client doesn't know the identifier when they interact with that post of the resource being created, it's really important that you don't return 200 OK. You have to return 201 because that's the created says. It says not only was the request successful, but it was successful and I created something as a result. Oh, and by the way, here's the location header on the response that tells me the canonical URI of that newly created resource. Because the client didn't know it when they executed the request, the server has to tell the client where it resides so the client can get to it if it needs to interact with that resource further. So when you use post for create, always remember to do 201 created, not 201 200 OK, and use a location header. Post can also be used for update as well. So instead of creating a resource, we're interacting with an existing one. You can see that there's a particular application. And in this case, I'm updating one property only. I don't need to put the entire body in there. And then the server can give me a 200 OK if that goes through successfully. And the reason why this is allowed with post is that because post is the only HTTP method that is not guaranteed to be idempotent. So what this basically means is that, and the HTTP spec is very vague about this. They say basically a post, the server can do whatever it wants effectively. So there's no protection against side effects or state changes or anything. So when you do post, the server can truly do anything that it wants to do. So it's not automatically retriable if you want to avoid state issues. So those are the fundamentals that I wanted to cover. We'll kind of hint about this stuff in a little bit or cover some of this stuff again later on in the presentation. The other thing that's really part about HTTP specifically, and this goes back to one of Fielding's original requirements for a truly RESTful API, you want things to be focused on media types. In HTTP specifically, this is kind of negotiated, they actually call it content negotiation, where in a request, a client can set an accept header that says, these are all the media types that I accept or that I understand. Can you please give me back a resource that conforms to one of these? Because that way I can parse it. And the content type header is set by the server on the outbound response that says, okay, I know what you asked for. This is the actual media type that I'm sending back as the response. And presumably, the majority of the time, this is one of the ones that the client supports. So clients and servers can negotiate with each other the resource representation that they want to use or interact with between each other via this content negotiation, these two headers. It's important to know that a media type is really, it's ultimately a specification with a set of parsing rules that determine how to read that particular resource or document. Like, if I work with a JPEG or a PNG, there's clearly defined rules of how to interpret those bits and turn it into an image. Same thing with any other text-based media type, whether it's HTML or XML or JSON. There are a set of parsing rules that determine how to ingest that document and make sense of it. And this presentation is largely about media types, or specifically the ION media type, because we need to be able to understand context or have contextual relevance within a document in order to understand how to parse it correctly. So JSON's great, it's super generic, it just tells you how to read names and values and objects, but that's not good enough for semantic data exchange between machine clients over the web. We need more information other than what JSON can provide. It's interesting to note that you can have subtypes, if you will, of a particular resource by including an identifier before in the slash here. So the first one is application JSON. Pretty much everyone knows what that is. But application foo plus JSON or application ion plus JSON, basically those two say, not only is this a JSON document, but it's a JSON document according to the foo specification, or a JSON document according to the ion specification. So you can create more specific types of a media type with this, this sub foo plus or whatever naming technique. And these don't have to be officially registered with IANA, the naming registry for media types. But if you want it to be a global standard, then you're definitely going to want to go through that process. Okay, those are the fundamentals. Let's get into like real design. How does this how do these principles manifest in real REST APIs, especially APIs that you want to make either globally accessible to the world or even just adhere to best practices so that even if it's for internal use cases, people or machines consuming these things work really well and cleanly. So let's jump in. How do we deal with Helios and JSON? As I said before, there's no spec. There's no specification that tells you how to do this, or at least an IETF RFC. ION is an attempt to do this. We feel that we have the best representation of a REST-capable JSON-based media type, and hopefully I make that case for you today. But ION is basically, as I mentioned before, this notion of resources and collections and links and whatever. ION is completely dedicated to full discovery of these things. And so let's talk about what that looks like in actual ION-compliant REST APIs. And hopefully you'll see that it's far simpler than you might see elsewhere with other competing specs or other initiatives. So there's this notion of an object. And in ION, an object is an object. Like, it's just a JSON object. There's nothing special about an object. But one of the interesting things about JSON objects, if you exchange between servers back and forth, a lot of times you need context to understand more about this object other than its native name-value pairs. Like, this is fantastic. I can see who this Bob Smith guy is or whatever, but from a media type or a Restful or web client perspective, I don't know really anything else other than this. Like, how do I get access to this resource later, over the web? Does it live at a particular URI? If so, like, what is it? You don't know this without starting to add in these RESTful or web-specific concepts and start, peppering them in your native domain model. That's not really super clean. So what ION does, the way it addresses this, is it introduces this meta concept. And meta is really just a metadata object. Pretty much anything can be in there. We'll definitely dig into this a lot more, but the idea is by having a simple meta property on a field, all the metadata about that, whether it's web-specific or REST-specific or additional information that's relevant for that particular resource, can all be represented in this meta concept. Now, me and the other people on the ION working group can't take credit for this. This concept was actually introduced by a conversation, I think in 2006 or 7, maybe 2008, between Tim Berners-Lee, the father of the modern web, and Mark Nottingham, who is on the IETF web spec review board. This isn't just something that just was kicked out of the air by a couple people. This was kind of thought of by people that have defined web for 20 years or 30 years. So it's rooted in people that really understand this stuff. And we'll show you how this can be beneficial compared to other alternatives. So this is a resource, a thing, right? What about collections of things? It's simple to just think of, let me just throw an array up there. It's a collection. JSON's got collections. It's defined as an array, right? JSON has arrays in its grammar. So I can just throw this in my document and I'm good. I've got a collection, right? You can do that, but there's a problem with this. If I just look at this, or maybe comma-separated values with inside of it, I can't get any metadata about this thing. What if I need to know if there's a limit on the number of items that are supposed to be in the array, or is there a min, max things? Like, what are the total options that could be in the array? You can't tell that by looking at a raw array in JSON. It's not built into the JSON grammar to provide the notion for this, but machine clients often need a lot more information than just an array. So you can do that by wrapping it in an object. And in Ion, we always recommend that arrays are wrapped in an object. And the reason why is because then you can assign a meta element to it. Right? You can't do this with just native JSON arrays. So this collection concept allows you to append metadata to represent whatever that array is. All sorts of information. What's the data type that's supposed to be in the array? The max size, max length, any validation rules for things that are in the array. All of that can be represented as a meta element, which you cannot do by using native JSON arrays in your data model. So big recommendation is if you're going to represent a collection of things, always put it in an object so you can have this meta capability. Machines need this. Even humans need this to a certain degree. Okay, so we have resources and collections of resources. What about linking? This is, again, one of the two most important things between this and state transitions that Fielding really drives home. It's part of the five requirements that he mandates REST APIs have. So what does this look like in a JSON world? First of all, at least especially with HTTP, or just REST in general, distributed hypermedia is paramount. Like, this is one of the most important things. If a document can't link to other documents or a resource can't link to other resources, you're not going to have a RESTful API. You're not going to have you're not going to provide value to clients to get access to a lot of information. And so to that end, every resource that is accessible over the web should have a canonical, unique URL. And the notion of a URL as an identifier kind of replaces the concept of IDs that most of us as software engineers are used to. We think of an ID as a number like 12857 or some kind of UUID or whatever, and we think, oh, that's the UID, and that goes in my database as a primary key. And that's the way we think as engineers. But the reality is IDs don't matter at all on the web. The only thing that matters are URLs. So how can my REST client get from this resource to the next? Right? It does that via URLs. That's the way that IDs are represented, or identifiers are represented on the web. So they exist, of course. As we saw that application/ID, they're there. We know that they're there, but machines don't know, nor do they care, because all they see is a URL. So IDs are effectively opaque. They exist for our internal needs and how we structure our data, but they don't matter for REST clients. Only the URL matters. And this is obviously critical for linking. So how do we do it? There is no, well, at least until now, there hasn't been previous specs for linking in JSON. There are a couple. There's this one other one called HAL, H-A-L, and I think there's JSON LD, JSON linking documents. But they're not specs either, right? They're draft initiatives by other communities. They haven't been formalized in an RFC. XML has this. It's actually called the Xlink specification. So like when you guys look inside of an HTML document, you see A, href, equal, that's considered an Xlink, specifically in HTML's terminology, an anchor. JSON doesn't have any native representation of this that's formalized in an RFC yet. So how do we do it? How does Ion do it? Let's go through a naive exercise of how you can think about linking, and if you were just going to add it to an existing resource. In the Stormpath API, if I get a user account back, and a user account is always stored within a directory somewhere, how does the account know what directory it's in? So if I have this directory property, what does that look like? What does that link look like to the parent or owning directory? The naive implementation is just to maybe create an object with an href in it. And it's very simple, right? href, I get it, it's part, xlink anchors, everyone has an href. Okay, I'll just put my URL as an href. But there's a difficulty with this, or rather a problem with this. An account, let's say an account is also a member of one or more groups, right? Very common scenario. What would my groups link look like if I do this technique? Oh, well, it's easy, right? I just create an object, and I have an href, and now here's the fully qualified URI to the particular groups that that account is a member of. Easy, not a big deal. Does anybody see problems between these two approaches? Like, why isn't this good enough, right? The answer, just in the interest of time, is that I can't see anything else about this. I have no clue that it's a collection. I just see a URI. I can't tell if it's a collection, maybe what types of data are represented within that collection. I can't interact with this or see this in a document and know anything about where I'm going to go or what I'm going to get. From a context perspective, this is very poor. I don't have the capability of describing information beyond, hey, go to this link. Xlink has this, right? They have notion of, in Xlink you have rel, R-E-L, which is a link relation that kind of tells you the nature of why that link exists or the purpose of it. So this isn't quite good enough. So how do we do this in Ion? Ion, in the metadata, we just include an href property. So this is good enough just to say that this particular resource is accessible at this particular href. And so this particular account has its own href. That's its canonical location. We recommend that every single resource that is accessible over the web self-describes itself via the meta href, the nested tag, because this will always make it easy for consuming clients to get access to that. So now, if we have this href property within the meta element, what do our links look like now? So now we can still have a directory member, property, field, whatever you want to call it. Instead of just a native href inside, now we have a meta element. And I'll explain in a little bit why it's important to do this, especially when we get to resource expansion, so that you'll see that Ion is very elegant in that it doesn't require you to alter your object structure. However you want to build your RESTful resources, all you need to do is add in a meta element. Yes? Yep. Absolutely. Most definitely. What do you what? It shouldn't matter if it's changing because your RESTful client should be able to react to dynamic URLs and interact them as necessary. URLs, remember, one of the core principles for fieldings in order to be truly RESTful is you can't have predefined namespaces or hierarchies in a RESTful API. I mean, it's static maybe from the perspective of your implementation. Like, I know that I have like an account resource and I've got a directory resource over here and I've linked them either in a relational database or a NoSQL database, whatever. That's your structure, but how you represent it to the client is kind of loosely coupled to your underlying implementation. So yeah, URLs can change depending on where your resources are accessible from. And your client should always be aware of that and capable of reacting to that. So why did we do this meta capability? So now I have a link to a directory, which is a thing. Now if I link to a collection of many things, now I can start adding more information in there that tell the client that this is a richer resource. So I have a groups link, and it's got a meta field with an href, just like the directory did. But now I can start adding additional information. In this case, we have a rel attribute, which is the same thing as a IANA relation type. And in this case, we're indicating that the thing at this location is a collection, not just a single resource. And there's a lot more stuff that we can add to the meta element to give a richer description of what's going on with the resource so that clients can get more information about this, present information to end users perhaps, and then interact with this resource as necessary. So the meta concept, either for a collection or for a resource, is extremely important. There's so much information that clients can glean from this that it's just not possible in normal, just kind of standard REST API or JSON documents. How many people here have heard of HAL, H-A-L, for linking? Okay, so there is kind of a HAL draft spec in the process. It's not codified yet as an IETF standard. Some people ask, well, what about HAL? Why doesn't Ion just use HAL's linking approach? And there's a couple of reasons. HAL, first of all, is extremely focused on primarily just linking, right? There's a lot more to the semantic web and Helios than just links. There's state transitions as well, which we haven't talked about yet, and we will. One of the other things about HAL that I personally dislike is that it forces you to define your links as a separate underscore links array within your resource. And so the way I look at that, if you guys want to think about making a truly great REST API, think of browsers, right? If I go to google.com or microsoft.com or, I don't know, hnrblock.com or industries worldwide, completely different industries and domains and data models around what they can represent, I need one browser to interact with all of them. A truly great REST API should be able to have one client that can work with any REST API. If you want to be truly Helios compliant and truly RESTful, the holy grail or the gold standard of being able to do that is to have a client that can work with any REST API. Now clearly the REST APIs themselves need to adhere to a media type that a client understands, and that's the whole point of Ion, is so that we can have one client type for every potential REST API out there. You know, we're in the very early stages, but that's the goal. That's the gold standard. That's why we're trying to work for this. So in the context of a browser that is truly Helios capable, when was the last time you created an HTML paragraph or a div or a document and you took all of your links within it and you just moved it to the bottom of the paragraph? Right? Nobody does that. So HAL forces you to remove your linking context out of your content and separate it into a separate chunk, which in my mind and other people who worked on Ion is detrimental, because anytime that you remove context or separate it from where it's most relevant, you start getting in problems in parsing scenarios, not parsing scenarios, but use case scenarios and stuff. So HAL forces you to change your document structure to rearrange it. Ion does not. Ion is additive, right? The meta element can be added anywhere. HAL requires you to adhere to a particular structure that removes context. And in that same vein, Ion is way more like HTML by design. Everything is in one convenient spec: linking, state transitions, which we'll talk about next. Transliteration between HTML and Ion. Like if you want to take an Ion document and generate an HTML page or an HTML page and turn it into Ion, well, not necessarily easy. It's far, far easier with Ion than any other spec that exists. So there are a lot of benefits to the Ion approach and keeping things context relevant. So if you've heard of HAL, that's why we don't do it like HAL. All right, let's talk about state transitions. Linking is the first critical part. State transitions are the next critical part for truly RESTful APIs. So let's talk about creating and updating. How do we create and update resources in a truly Helios compliant REST API? So most people today look at a REST API and they say, oh, I want to create an account, or I want to create a group or a directory or whatever. How do I do that? Oh, well, let me go read the docs and I'll figure out how to post this stuff, or put, or whatever the control or the method is in order to get that information into the REST API. This is bad. This is absolutely not Helios. It's not RESTful, right? The RESTful resource that comes back from the server needs to tell the client how to do this stuff so that the client can maybe represent it to another machine or to an end user, human being, and then the human being or the machine client can then decide based on the document structure what to do. How do I submit information? If you have to go read documentation to interact with an API, it's not RESTful. Like, if your browser goes to google.com, do you have to go read docs on figuring out how to interact with google.com? No, you just click links and it just works. Or I can enter in some data in a search field, hit submit, and it posts, and then they give me back results. That's Helios, right? Every website you visit works the same way for one browser. So this isn't Helios. So how do browsers do this? What's the way to send information into a particular resource or location? How do I transition state from one to another? And the answer, at least in HTML and Ion, is forms. Right? It's funny that this concept, especially to a lot of RESTful people, are like, oh, wait a minute, forms? That's so obvious and simple. Like, why haven't we thought about this before? And I posit the same question. When Stormpath originally built its first API, and most people who build REST APIs never think of this concept of how do I describe the information that's available so that a client can know what to send, to post, or to put. So what does that look like in Ion? Well, what is a form, first of all? A form is two things. It's a link to a particular location, right? So I have to know where to send the data. And then it's a collection of form fields that describe the data that can be sent, right? And so we have those two things already in Ion. We have the meta href capability to define a link. We've also defined this collection concept of an items array with a meta property. So if you join those two things, you can already use those two foundational concepts to create forms. So here's an example of what a form could look like. Let's say I want to be able to create an account. Well, I've got a meta element off of this object, meta href. I've got a link relation type of create form, which is an IANA approved link relation type, by the way. So we're not changing the definition of how this stuff works at the global web. HTML's had this for decades. We're just leveraging it in a JSON kind of format. And then there's a method, post. And then I've got my collection, a collection of form fields. And so each one of these JSON objects within the items array is a form field representation in JSON. So in this case, this is a simple, I'm going to create a simple user account, and I'm just going to specify every user account has to have a login and a password. So we're not going to have a lot of time to dig into the intricacies of Ion form fields, but at a high level, you can understand that Ion HTML form fields, for as great as they are very UI-centric. They describe user interface controls more than they do the data itself or restrictions on the data, right? So like, if I have an option button or a radio kind of control in HTML, it's telling the browser how to render this control so that people can interact with it. Ion takes the stance that data is more important than user interface controls. While it is capable to transliterate between the two, you'll see that Ion's vocabulary of how to describe data, requirements, restrictions, constraints is much more rich than HTML, and you can get a lot more done from a data perspective, which is ideal for a data interchange standard, which is what Ion is designed for. So in this example, you could see it's a simple form that you could envision in HTML, nothing special there. And Ion has codified a whole bunch of lists of name-value pairs for types and data semantics around forms. Here's a little bit more robust form that might give, kind of whet your appetite a little bit for, how do I have complex things? So in this case, I'm going to create a user with a username and password, but also maybe I care, I don't know, I'm doing some geo website. I want to see which continents they've visited in their life. And in this case, we've actually got a type of set. So Ion forms support native collections for data submission. In this case, we have to specify there must be at least one item in the collection before it can be submitted, but it can be no more than 7. And here are the various options, which, surprisingly, is a collection of form field options. And so this should look and feel like an HTML form just in JSON format. It shouldn't be very surprising. And there's a lot more that Ion can do like this to give you much more robust capabilities for forms. Not only that, but and unfortunately, we're not going to have time to go into today, but Ion forms are way more robust than HTML forms. Like, what if I've got a user object that has a company object, and inside of that company object, it's got an address object with all this stuff? How do you submit that in HTML in a form? It's kind of hard, right? Like, HTML forms are flat, right? You just a bunch of name value pairs and that's it. You can come up with schemes like using dotted notation or dashes or whatever, but HTML was never really designed for that kind of use case. JSON, on the other hand, very commonly describes complex structures of objects nested within objects. Ion even supports nested forms. So I can have a field in here, like The outer one is a user, and the inner one is a company, and the company form field is of type form that has its own form. So the idea is that you can build very complex data structures via forms and ion nested forms to submit one resource document back to the server that contains everything that's necessary. And every form tells you the data restrictions or the requirements for each nested element, something that's not possible in HTML. Yes? Yes, so that's a great question. I'll touch on that in a little bit. It's kind of like a schema, but it's more powerful. And I'll discuss that in a little bit. So posting, this is a create scenario. I'm creating stuff, not too surprising. But a lot of people don't think of forms as being used for reading as well. So if I could submit data, how do I query information? Like, what fields are queryable? Can I order things, or sorting, right? Am I allowed to sort the results back, and how do I do that? Yes? Yeah, forms within forms is not represented here. This slide doesn't cover that. If I was going to have another form, it'd be like, I would have a name field of organization and type of form, and it contains as a nested object a form that explains the structure of what that organization has to look like. So yeah, that's not demonstrated on the slide, but there is an example of that in Ion. I'll show you the website in a little bit. So creating is obvious. People are used to posting forms on HTML pages. What about reading though? You can do search-based query as well. If you look at the top, the method here is changed to get. The link relation type is a search form. And so this form describes all of the queryable fields. Like a lot of people, when they look at, like if you look at a searched field or whatever, there's no concept of that. But sometimes certain websites have like an advanced search that has like a drop-down with different fields. It's the same thing. You can give clients or end users very rich capabilities of figuring out how to interact with, how to get data, how to query for it, how to order it, how to interact with a particular collection. And if you look at here, this particular URI is, at least as a human, we can infer that this is a collection. There are multiple, I'm searching across all of my users in this case. I can search by username or email or given name or surname. So forms are as valuable for data retrieval as they are for data input. And they're fully self-describable, fully queryable, right? You don't need to hard code, oh, in order for me to find data, I have to go to this URI, and it's always going to be there, and it's always going to have these fields. You just don't know sometimes. So to sort of hint on that question, we've talked about forms and data structure. Well, what about schemas? We've heard people talk about schemas. There's this draft spec called Json Schema. And my perspective and those on the Ion committee is that this is just not needed. Like, REST is not a relational database paradigm. It's a paradigm mismatch. You don't need to describe your data up front or ahead of time or ever until you need to submit data or query data. And so forms, they do the same exact thing. If you looked at this form, this is a schema, right? I've got a username field. I've got a password field. Not only do I have a visited continents field, but not only do I have the field, but here are the values that are allowed to even be in that field. So like you can do restrictions in SQL when you like define tables in Oracle for like enums and stuff like that. This is the same thing. If you look at this, this is no different than a schema. From a structure perspective, the huge difference is that the schema might change tomorrow. The form might change tomorrow. Maybe this visited contents field is no longer there. Maybe a new field has been added, right? This stuff can be dynamically changing depending on what the REST API needs to or requires in order to get access from a user. So forms are effectively schemas that are not limited by strong structure that has to be backwards compatible. Now, that doesn't mean that you can't choose to utilize a form and make it strongly structured and that it never changes because you want to simplify your life. But my point is that forms, just by their definition, don't require this notion of strict data structure. And especially when you use something like a NoSQL database or a schemaless database, this is a lot of benefit and a lot of value because you can change that stuff easily over time. So And the last thing I'll mention on schemas is remember one of the main points in fielding's requirements for a RESTful API. REST is about dynamic typing. Schemas are almost completely in contradiction of dynamic typing. A schema is, let me define the type up front so that I can leverage things, everything has to conform to that later on. That's not truly true, but that's how most of us as engineers think of schemas. Dynamic typing is all about, schemas can change, they can evolve over time, you can modify them, right? And not only that, but the client needs to be made aware of when they change and when they evolve. Forms allow you to do that, schemas, at least conceptually, don't. To be fair, JSON schema can be used in a dynamic way. You just generate a different schema every time your data changes. But our perception at Ion is that it's a little too tightly coupled, at least in concept, to what traditional schemas represent and how they function. Like, what's my data fields that need to be there? Forms do the exact same thing, they're just dynamic. Okay, so this part, and I'll try to wrap this up a little bit. The really important things that we got through in this presentation were linking and state transitions via forms, either reads or writes. If you adhere to these principles, you'll have a RESTful API. If you go to your base URL and you get back like an initial document that's maybe like an index document that tells you how to get everything else, you'll be fully RESTful, and documents aren't needed, or rather documentation is not needed if you're going to do it the right way. All right, so those are the most important things. Let's just cover some kind of HTTP-related things around REST. What we just talked about from a RESTful perspective, linking and state transitions are RESTful in that there's no protocol-specific things you have to be aware of, right? I can send and receive documents over HTTP or TCP, it doesn't matter. That document structure doesn't have to change. But when you have REST within a JSON, or REST with an HTTP focus, there are some HTTP things that we want to focus on, or that could make our lives easier. We get a lot of questions sometimes about base URL. What should my base URL be for my API? How do I? The answer is because REST clients don't care about URLs other than the fact that they can traverse them, it doesn't matter. But for human beings' purposes, we typically recommend starting off with your best foot forward and creating something that's nice and intuitive and inviting. Nobody wants to look at the bottom one and be like, oh, they care about my RESTful experience, so I've got to go dig through all these things in order to figure out how to interact with this API. Again, a client doesn't care about this, but people do. A lot of times we get questions about, what if I visit this with a browser versus a REST client? Do I show JSON or do I show HTML? What am I supposed to be doing here? And the answer is that you can do both, right? Content negotiation allows the client to specify in the order that they prefer what resources they want to get back. So if a client specifies that HTML is a higher priority in their accept header than application JSON, you can return an HTML document. But Stormpath actually doesn't do this. When you interact with our API, we give you JSON anyway, because, well, almost always, presumably, application JSON is in the supported list. So even though you prefer HTML, if you still support JSON, we'll still give you JSON back. And the reason for that is that the majority of our customers are developers, and they just want to see what the REST API is doing, like what the data structure is, what it looks like. And it's far more convenient for them to interact with that API than it is to see an HTML document that masks or hides the structure of the JSON. So, but again, content negotiation, you can leverage that however you choose. Versioning, this is actually pretty important. We get questions like, the Stormpath API, or basically the vast majority of SaaS-based companies on the internet adhere to the top URL-based scheme for versioning. But the question is I've got an API, do I hard code the version number in the URL, or do I use this media type approach? A lot of people don't know you can use media types, and maybe like in a meta element, you can have a version number, or sorry, a version field within meta that says this is the version of the structure that I'm interacting with. You can also version media types with I didn't show it here, but at the end of Ion plus JSON, you can have semicolon v equals 2, and that means version 2 of the Ion spec. So you can do that via content type negotiation and media types. Most people don't know how to do that, so Stormpath and most other people I've ever seen does the top URL, but I'm here to tell you that this causes problems. So in practice, what we have seen is people will have this they'll take URLs and they'll store them in their own data stores, their databases or whatever, so they can get access to resources later. What if this version ever changes? Now, it's not the end of the world, because a truly RESTful API should be able to take a request to that endpoint and redirect it to v2. Right? You can use a 302, HTTP 302 redirect, location or resource moved or whatever, and the client should be able to get access to that resource. The problem is if the client is hard-coded to understand the data structure of v1 and it sees v2, it might break. And so that means the client is A, not Helios compliant, because the fact that it's even breaking on a version change means something's wrong. And 2, people store these things in their database, and so when they go to interact with it, they want it to still be there. So if you're starting out with a new REST API and you can get away with media type negotiation, strongly, strongly recommend that you do that. You will just save many problems downstream. Just be aware that a lot of people, customers, even some engineers don't understand about media type negotiation for versions. So that's sort of a customer education thing. Yeah. Sure. Yeah, so the statement is, the reverse of that is true. Like if you're always coding to v1 on a media type, you don't want that to change under the hood out from underneath you. And that is true, and that's entirely up to the API implementers as to how long they want to support v1. And that's just a business decision as to when that occurs. The point that I'm trying to make is that the URL itself doesn't codify that in the URL, so you're not stuck with that forever. The clients can upgrade, and over time, the old ones can go away, but none of the URLs or the identifiers have to change. So content negotiation, we talked about this just very briefly. The way the accept header works is that traditionally, or rather, there's this Q parameter, which stands for quality. You'll see it hanging off of this last one. And this is a precedence indicator. So without that Q, everything defaults to 1. And the higher the number, the higher the preference by the client. If 2 things are not declared with a quality number, then they're considered 1 and they're considered equal. And at that point, the order in which they occur is conventionally determined. It's not mandated by a spec, but it's convention that the ones in front of the same quality rating have a higher precedence. So that's typically how servers can negotiate content based on the accept header. Conventionally, often a resource extension will override the accept header. This can be useful for simple use cases. Maybe you're using a browser and you can't set the accept header easily. A lot of developers use command line tools like curl or HTTP or Postman. They allow you to change this stuff, but maybe a browser doesn't. So if you support this, it kind of overrides the accept header. We typically recommend not to do this because it's far more powerful to have the same URI support different resource formats if you want to support that user interface. And how do you figure that out? You have different links. I have one link to my JSON representation. I have another link to my XML representation. Same URI, but the media type meta header can tell you what the data type is, or rather the media type is. Style guide, very briefly. This is very minimal. JSON is traditionally a camel case language. JS in JSON stands for JavaScript, or JavaScript is traditionally camel case. So we recommend that you just name your variables using camel case, not underscore, not dashes, because it's just not conventional. And so it's more important to be conventional, and you get better understanding across a global community than trying to impose personal preferences. We get questions about date and times. How do I represent dates and times in my REST APIs? This is an interesting question because there's been a text-based standard for representing these things for decades, and it's called ISO 8601. There's no reason to reinvent the wheel. So we strongly, strongly recommend that all dates, times, and timestamps use ISO 8601. And even more specifically than that, always represent your timestamps as UTC. It's easier for a client to look at that UTC value and represent it as local time than it is for the server to have to worry about that. I mean, you could use date headers or rather time zone headers and stuff like that, but it's a big pain. And more importantly, at least for servers, a lot of data stores don't represent time zones faithfully. And so if MySQL for years has had problems representing time zones on timestamps. And a lot of other databases do too. If you always represent your data in UTC and you normalize that across the board, you're going to find, and your customers will find, that there are far less integration problems if you all agree to use UTC. Ion specifically represents these formats in field types of date, time, and also partial times without time zones, like P time, P date time. We recommend using full versions whenever possible just to avoid confusion. And so based on this, most people will want to see these in their REST resources at some point. When was that resource created? When was it updated? A lot of times this will be queryable. So let me find all user accounts created after September 1st. You know, which accounts were updated in the last 24 hours? You can do all sorts of kind of queries if you represent these things as queryable fields in your resources. And again, stick with UTC. We're getting pretty close. I got about 15 minutes left. I'm going to try to wrap this up in the next 5 minutes, and I'll take questions. One thing I want to talk about really quickly that Ion really works well with, that a lot of people find very valuable, is something that we call reference expansion or entity expansion or link expansion. And so this kind of behavior exists to answer this question. What if I want to get an account and its directory in a single request? Like, I don't want to request to get the account and then execute another HTTP request to get the directory. You can do that, it's totally viable, there's nothing wrong with that. But if I want to reduce the number of round trips to the server, and the server supports this at least, you can do this expand concept where when I get a resource, I want to expand the directory while I get the resource. And so in the meta field, as you see up top, you can have like an expandable meta property if you want. This isn't codified in Ion yet. I don't know if we will. But the point is you can use meta for your own behavior too if you have an Ion or a media type that identifies this. But in this case, the resource can say, these are all of my expandable properties. If you want to get me and other things included in the same body, then you can. And so in this case, if I get an account and I expand this directory, the directory is included in line with the resource. Now, this is one of the truly beautiful things about Ion in our perspective from a design and simplicity perspective. If you look at that link, remember it was the link before with just a meta field? If I've expanded it, the document structure doesn't change. There's no change to the structure. It's just populated more data in it. So the client doesn't have to say, oh, I'm dealing with a link now, and now I have to change how I deal with that link to get more properties. A link is nothing more than a meta element. But if it's fully expanded, then it's the meta element plus some extra stuff. You don't have to change your document structure with Ion. It just works in line automatically. Very clean. So we can, collection pagination is another thing. If I'm interacting with an HTTP API, let's say I've got hundreds of thousands of things in a collection, how do I deal with that? You don't want to necessarily return everything in a single REST response. That could be a huge amount of data. It could be bad for performance. So how do you do pagination? You can ensure that your collection resources, /applications or /users or whatever, support query parameters. There's two approaches for this. There's usually specifying an offset and a limit query parameter. So what's my offset from 0 in that collection? And then the limit is how many results am I going to get back on a single page within the overall page set. The other approach, other than an offset, is a cursor. And that's typically some opaque string value, maybe like a JWT or something, that has this information internally that the server can use to go find where in the collection it needs to get the next page from. We typically recommend using a cursor whenever possible and keeping that opaque from the customer so they don't ever have to worry about this stuff. But in either of these two scenarios, ideally, the client shouldn't have to worry about what these query parameters are. Now, you can make them available in a query form, right? The whole point of forms is to make this discoverable. But it's even nicer if they don't have to worry about that. And you just provide links that tell you how to get to the next page or previous page in a result set, right? So these are links just like any other, first, previous, next, last. And the client doesn't have to know, how do I take that offset parameter and the limit parameter, and I'm going to construct this URL and add these query parameters. You don't have to worry about that. The links are there, ready to go to access those particular pages. So because they're discoverable and they're self-represented, clients don't have to worry about this computation or calculation techniques to figure out how many pages or whatever. Now you could have like a side, that's the other thing to represent or to kind of point out in a collection resource. The collection resource is itself its own resource. It's got its own property. So there's links to other pages. I didn't represent it here, but you can have a size property that tells you how many results are in the overall collection. So even though maybe I'm only looking at one page with 100 results, maybe my size is like 125,422. So you can give a whole lot of extra information about that particular collection in the collection resource. So the collection resource is a first-class REST citizen. It's got its own properties. It's got its own links. You can treat it like any other resource. Get some questions about sorting. Like, if I want to get all accounts ordered by surname, given name, descending, I didn't show the form here, but this would be represented as a form, and you would have maybe orderable properties with a collection of form fields that tells you each one that's available, or rather options that can be selected, and then you can have ascending, descending for each one of them. So this would be discoverable by a client using a form, but this would kind of be what the request looks like when the form is parsed and then submitted via the GET. So you can do order by, you can do cohorts, you can do all sorts of stuff as long as it's discoverable via a form. And so search kind of looks like the same thing. Again, discoverable by forms. So how do I find all accounts with a company.com email address that can log into a particular application? This is kind of a very specific business use case, but you can see that these things can get complicated over time. And you'll see that URI structure and query parameters can give you this stuff out of the box very easily. So I'm accessing an application /app ID /accounts collection. So those are all accounts within the application. But I'm going to do !email equals company.com. And I'm not sure, unfortunately, I didn't have time to show you the form, but you can represent that email as a form field in the search form. And then you can also specify, Ion has this notion of a pattern attribute on a field, that you can define patterns that are available or valid for search criteria. So you can specify wildcards, starts with, ends with. Those would be discoverable via this pattern field. And that kind of looks like, you can specify different types of searches, maybe filter search, kind of like Google or Bing or whatever. You put in one text box, one field, and you just type whatever you want, hit enter. We call that filter search. That's kind of Q equals whatever. Or you can search on individual attributes. This is more like the advanced search where there's different fields that represent the types of things that you can search against. And again, these would be discoverable with forms. So this just gives you an example of starts with, ends with, contains. I will mention, if you can avoid contains, do it. It's a very difficult computer science problem. Elasticsearch, relational databases, NoSQL databases, they all perform very poorly when you do contains clauses. Now that's different than finding a token within a string using lexical analysis. If you're truly trying to do, does this fragment exist anywhere in a particular string, it's a very hard problem to do at scale. So I would avoid contains entirely if you can get away with it. Starts and ends with are a lot easier. You could do range queries. So like find all accounts created between September 1st and the 15th. You can do this in two ways. You can create two form fields in your search form that tell you what the begin and end time frames are, right? Here's a min and a max that are supported by Ion. It has min max values for form fields. We're still determining if we want to create a range type in the spec. So that might look like this. I want to find all accounts created. It just uses mathematical range notation to as a single value as opposed to two form fields. You'd be able to specify one. That's still in discussion. Talked about the pattern already. Here's a question a lot of people ask about. How do I represent many-to-many associations in a REST API? For example, a group can have many accounts, and an account can be assigned to many groups. So the way we recommend doing this, and we researched a lot about this, and how to do this effectively, and how to make sure that it's compliant with HTTP caching and all this other stuff, the really only good clean way to do this is represent each association as its own RESTful resource. So in this case, we have this notion of a group membership, and this is kind of what it looks like. So I've got, again, it's got its own href, its own meta href field, and forgive the ellipsis, it's not, it's just I'm chopping off some of the text. But in this case, I have a membership that represents the association between an account and a group, and that group and the account are represented as their own links to those actual resources. The reason why this is beneficial is because if I want to disassociate those two from each other, how do you do that? You can have like accounts/account ID /groups/group ID and send a delete to that. That's really kind of awkward. And representing that as a discoverable href and a lot of links is kind of difficult and burdensome. Whereas if I want to just disassociate these two, get the account out of the group, all I have to do is delete the membership. I'm not deleting the account or the group. I just delete the group membership resource itself, and now that connection is broken. The reason why this is valuable is that HTTP caching, if you want to delete a membership and you send that delete through, the caches can purge that resource. If you do it a different way, there's no resource to delete, and that it's not obvious that resource is gone. So for caching reasons and other things that we don't have time to talk about, we represent keeping these as one-to-one relationships. This is just a way of representing the collection in two different ways. I'm going to pass through that. This is a question I get a lot for advanced use cases. What about async or long-lived operations? Like, let's say I have an API that does video encoding, and that might take 5 hours, for a large video, gigabyte, who knows. I can't keep or I shouldn't, if I want to scale well, keep my socket connection open for my HTTP socket open for that entire time. And HTTP supports that. So for example, let's say I want to send an email, right? This is asynchronous by nature. I don't need to keep my connection open while I send the email address. Maybe it's queued somewhere until it goes out to a mail service. You can do this using the 204 in HTTP for accepted. So in this case, I'm sending an email, and my response body is that actual email, but now has a status of queued. And it's important here that it's not 200 and it's not 201. It's 204 accepted, meaning I've accepted your request, but I don't have the result of that operation yet. But what's important here is that it's giving a location header so that the client can go check that periodically whenever it wants. Now you can set other headers and things like, for example, the expires header to determine when that thing's going to go away or how often they're allowed to communicate with you. But the idea is that this is a resource that has its own status, and then maybe later on I'll query for that endpoint again via a GET. Again, this can be discoverable via a link to determine if it's async or not. And in this case, I've pulled that, and now it tells me that resource is going to expire. So when I send an email, maybe that email resource it's not going to be around in perpetuity. It's not going to be around forever. Maybe at the end of 30 days, that URI is no longer available. I can't get to it anymore. And that's what the expires header says. It says this resource is not guaranteed to exist after this particular timestamp, so don't count on it being there for forever. Final thing I'll finish up with is batch operations. A lot of people ask, well, how do I do all this, many things at once? I want to create 20 accounts right at the same time. You can do 20 different individual requests, or you can try to batch them up. So, or for example, what if I want to delete all company.com accounts? That's a big batch operation that impacts many different resources simultaneously. You can do this, but there's a huge caveat that I'll talk about right at the end. We already have a collection resource, right? So we should use it. So maybe I want to post to the accounts endpoint. And instead of sending one thing in, I'll send a collection of account resources, one per element in the items array. So you can do that, and you can get back a result that has a collection that tells you all the resources that were updated or created. There's a huge problem with this, though. While it's better for performance on individual requests, this completely bypasses caching. What I mean by that is, let's say that I create an account and I get back a resource href, and I can cache that in HTTP caching server because of the caching header tells me I can keep it for 20 minutes or whatever. When you do a batch operation on a resource, and that resource is in the batch, the batch itself is its own resource. HTTP caching servers can't look inside of it. They treat it as its own resource. They can cache that independently, but there's no association in HTTP caching semantics between the account that I created over here and the batch delete I did over here. Ideally, you want that account that's been cached to go away, removed, be purged from the cache if you delete it. And if you do batch operations, you completely bypass all of that stuff. So be very careful about using batching operations in your REST APIs. At Stormpath, we typically prefer that batch operations are actually done as individual requests because all of the caching semantics are maintained. Things can be purged cleanly from the clients. Things that have been in the client for half an hour or whatever can be cleaned up immediately instead of being accessed as if they still actually exist. And then when you go try to do something, you get back a 400 error because it's gone, or 404 missing. So there's a lot of problem scenarios that you avoid if you avoid batching. Sometimes it's not avoidable depending on your problem domain or your use case. Just be aware of the repercussions of this. Here's an example of what maybe a batch resource would look like, right? Batches would have their own statuses and representations as its own resource. Finally, I will say one thing about errors. It's always good to have an error body that represents what went wrong, why it went wrong, preferably an individual status code that's not just the HTTP code. HTTP only has like 24, I think, total error codes across 400 and 500 status codes. That's not enough to really accurately represent what's going on in your application. A lot of times things will happen that don't cleanly fit in or don't give you the client enough information as to why something failed. Just because it's a 400 doesn't tell me how to fix the problem. Additionally, what's really nice, individual error codes that are specific to your app can be used for internationalization, right? So I can look at any one of these given error codes. Maybe I have 50 or 100 in an application. Every one of them can be translated to an internationalized, localized message, depending if you need to support internationalization or not. Unfortunately, I've run out of time. I'm going to have to skip over some of this stuff. But if you have any questions, please feel free to come up to me at the end of the presentation. Oh, the next question is, ION is starting initiatives to go into the IETF as a formal RFC. So we actually finally have a standardized single spec that addresses all of these concerns. So ION is really intended to be what HTML is to browsers, ION is supposed to be for REST clients. So that's the goal and the scope of the spec. If you're curious about it and maybe you want to participate or ask questions or if you're interested in helping out, the project's available at the ION working group, ionwg.org. You can read the current spec and the draft ION. We hope to enter the RFC channels shortly. So thanks for your time. I appreciate it. I'm open for questions if you guys want. I know that we don't have a whole lot of time if you need to get to your next session, but I'm up here for a little bit. Thanks. Yes? How do I feel about making them discoverable? So the question is, what's a good pattern for making the forms discoverable so that they're available for clients? I didn't have time to get into this, but one of the interesting things about ION forms, or links rather, remember a form is just a link with a collection of form fields. It's discoverable in that it's its own JSON field, right? It's called find accounts. And so within that, you can actually have a label with a description, like either after the meta or even in meta, that gives an end user a description of what that form is used for, why it exists, how to interact with it. You can add that as a property, because this is, again, just an ION object like any other. So you can add a description field if you want to, or a label or whatever, and that will tell end users what it is. But the ION spec knows that this is a form because of two reasons. There's a meta field, there's an items field with form fields, and there's a rel of search form, create form, or delete form, or whatever. And so one of the things about ION is that the rel field isn't required because it will default to the attribute name as the link relation if you want it to. So if I didn't define this as search form, the link relation would be defaulted to find accounts, which is not an officially approved IANA link relation, but it still conveys semantic meaning to anyone parsing the document. But you can explicitly identify certain link relations to make it obvious what the purpose of the form is for. And if that's not good enough, then you have description fields and stuff like that. Yes, so this example, it doesn't really, I should have shown maybe the href. This resource, you can think of this as an application resource, right? As the properties above it, like name, description, what the application's href is. And then this is just a standard link within the application resource. So in the account resource, for example, I might have like a find group link that tells me, oh, I can search across these accounts groups to get back only the one that I care about that might be assigned to the account. So yeah, this is just a JSON field in the resource of note. Yes?
So this is kind of analogous to spec or random, where I can find the types back. So in random, I think I would say, oh, this resource returns this stuff. But you put that into the
Absolutely, and it has to be. It has to be, because if it's not in the response, it's not RESTful, right? REST is all about state transfer. The resource that comes back needs to have all the state that's necessary in order to figure out what to do next. If you have to go outside of the resource representation, I mean, maybe the RAML document is a link that you can go get from the meta field. Like you can look in the meta and get a RAML document to come back. But my posit is RAML is not necessary when you have forms. Like if it can be embedded inside of the document, the client can discover it. The structure of what's available is already codified in the form. You don't need an external specification like RAML or Json Schema or anything because it's already there as part of the ION spec. Yes, you have to dynamically discover it, but you have to if you're going to call yourself a RESTful API. That's a mandate by fielding, right? Fielding states static types are not allowed because they're not scalable from the internet global sense. Well, it depends on how the client's written. Like if we give you an SDK that has hard-coded concepts of an account object and a directory object, that's going to fail, and it's wrong according to fielding at least, right? That's not good. Instead, the SDK needs to be written not like that, but the SDK needs to represent, here's a form object, here's a field object, right? And you code to that API, not a hard-coded representation of some static class or data type. Because if you do that, you're making your API rigid. It can't adapt over time. It can't deal with different scenarios. And the clients are stuck to that API for forever. And like API longevity due to data type discrepancies is a real problem at scale. Real problem. Netflix, man, you can talk to them for days about the problems they have with that. It's a real difficulty. Yes? Not the header, the media type. Well, you can do it as part of the media type in the header, the accept header. You could say application ION plus JSON semicolon, version equals whatever. The other approach is that you just look in the meta element for the version property as it comes back, and then you know what version of ION you're dealing with. In that case, you can provide an HTML document that gives them links that they can click on. Like that's truly RESTful. They can see these are the different versions. REST is not about browsers. It's about data interchange between clients and servers, right? So browsers are specifically about human interaction with HTML. So it's a different paradigm. It doesn't directly apply. That said, if you wanted to provide a query parameter that people could, there's all ways of solving that issue, but it's kind of not relevant from a client-server perspective. Hopefully that makes sense. Any other questions? Okay, thanks for your time, guys. Talk to you later.